I built 4 Dactyl Manuforms or similar variants, and I've been using them for about the last 8 months. Now, Dactyls are sort of considered the gold standard, if you like, of homemade ergonomic keyboards. And for the most part, I have been really enjoying using the ones that I've built. However, in the last few weeks, I've started to suffer with a bit of thumb pain. And that's something I've never suffered with throughout my entire software development career. You know, which isn't exactly a glowing endorsement of a keyboard that's supposed to help in that regard. We've got a lot to unpack here. Now, I've made wired variants, Dactyls, like this one, which this one's running on QMK and obviously has a TRRS cable connecting the 2 halves, USB cable into the computer. That's a permanently wired solution. That one's got OLED screens in there too on each side, which is only really useful for telling you sort of which half you're in. You can obviously put whatever you want on there, a bit like the software review, which you can check out up there. The wireless ones, slightly different. No screen on there because obviously a screen would completely drain the battery unless you're using one of the newer type screens, which we'll come on to later. Differences with the wired one is obviously this is using a nice nano controller board. Got a reset switch there on the bottom, charges with the USB port there on the back, and I've also got somewhere on here, yeah, I got an on-off switch buried in there as well, just so you can toggle that off. Of all the ones that I've built, they're all actually kind of variants on Dactyls. A true Dactyl Manuform has got a slightly different key cluster with more keys, and I purposely wanted less keys and a lower slope, but you can see here the difference between these two just about. Basically, this one's got a much lower set of keys as opposed to that one that's got a higher key cluster against the other ones. So this is primarily a review of Dactyl Manuforms as the finished article. I am going to go over a little bit what's involved in building one of these wireless versions, simply because it is a very involved process and I wouldn't want anybody to set off on this path not thinking that that's the case. If you're thinking about going down this path, you're perhaps wondering whether you've got the requisite skills to pull it off. Well, let me tell you, I've got no real experience in soldering and my tutor has been YouTube. But if a cack-handed monkey like me, I mean, my hand's about as steady as an epileptic geriatric at a strobe light convention. So if I can pull this off, I'm pretty sure that you'll be okay. So I'm going to cover briefly making one in the next section, but by all means, if you're just interested in finding out what one of these is like to live with and use, by all means skip ahead to the next bit. So with the Dactyl, perhaps one of the most positive aspects of it is that you can choose exactly what you want to go into a Dactyl. So you can see on these, the couple that I'm showing you here, this one has got very nice, what I think are very nice, Oil King Gateron switches in here. Not very fancy keycaps at all. These are just bog standard DSA caps I got on the cheap somewhere. But I think that's got a lovely... This other one, the wired one that I built here, this is using keycaps from Signature Plastics. I think that they're Alchemy ones, which I've stuck on here. And this one's got Bobby U4 switches. And again, no slouch when it comes to how it feels. You can hear, I don't know if you can pick this up on the microphone, but there's a bit of switch ping there compared to the Gateron Oil Kings. But the point is, you can have whatever you want in here. You can have whatever case colour you want, whatever case layout that you want, whatever sort of thumb clusters that you want. And as I mentioned before, I chose a different thumb cluster than the standard Dactyl Manuform, which has got a lot more around the thumb area, just because I didn't want a bunch of different keys to have to navigate my thumb around. So whilst you've probably got a good idea of what you want in terms of switches, layout and case, you might be a bit in the dark about what to use in terms of all the internal components. Well, I just basically read a whole bunch of blog posts, watched a whole bunch of YouTube videos on building these Dactyl Manuforms and just made up a parts list of what I thought I needed to do. Basically just copied what other people had done. So I'll go through some of those things in a moment. But the main point with a Dactyl Manuform is obviously you're trying to get this concave keywell, which is, you know, that's the kind of bit that you're going to all this effort for, because that's the sort of thing, because of that shape, you can't just buy a flat PCB and stick switches in it. This is what makes a Dactyl such a pain to build, because you've got to either go the route of hand wiring each switch to each switch and make a kind of grid layout of connections, or essentially do the same thing but with little single key PCB switches and wire those together, you know, but this is what you're going for, which is a kind of homemade version of the sort of layout that things like the Advantage line of Kinesis keyboards have been producing for years. This is the 360. More on that next time. So unless you're a 3D CNC cutting kit or like a lathe or whatever, you're going to be making one of these cases with 3D printing. Now, I didn't want to go down the rabbit hole of 3D printing myself, so I got mine printed for me. I used a company called Wilder Builds, which is in the US. I'm here in the UK, and they were fantastic. Andrew is the owner there, and he was very accommodating and did a great job with these prints, and I never had to wait more than a few days to get them. So like I say, I think I've had 4 of these so far. There's enough hassle building one of these if you're not into 3D printing without going down the rabbit hole of trying to figure out how to 3D print something. So there's a cost obviously with doing that as opposed to printing it yourself, but again, you know, probably worth it. Other considerations are whether you want to have things like these OLED screens in or perky RGB LEDs on each of the switches. As a user, I'm not really convinced of the utility, especially of the perky LEDs. I end up just switching them off anyway. I did, when I built this one, solder in LEDs on each of the keys, but as I'll explain later, I'm not actually using that. The OLEDs are useful to some degree because you can use them, you can put whatever you want on there, but also it's useful if you've got a bunch of layers to know which layer you're on, because what you don't get on these typically is little individual LEDs, which you get like something on the Moonlander or the Advantage 360, which will tell you what's going on. So OLED screens definitely useful, but standard OLEDs no good on wireless builds because they drain the battery. But you can now get Nice Nano do a nice view, which is a much more lower powered screen, so you could potentially put that in one of the wireless builds and have a battery that lasts a decent amount of time. But as you're making it, the other thing you need to think about is every extra thing that you add in here is going to add some complexity, some connection that could go wrong, some bit of software that you're going to have to configure down the line. My advice would be, if you've never built one before, go the wireless route, skip the LEDs, skip the OLED screens, just go for something simple. So yeah, with this wired one, I actually went to the hassle of soldering in LEDs on each one of the key switches. So that's 4 little pads on these tiny little LEDs on each one of the key switches, which if you're not a dab hand at soldering was a bit of a pain. And quite frankly, by the time I got to the end of it, I was so sick of soldering that I never actually ended up wiring up the LEDs. The LEDs are there on the PCBs, but I could never be bothered to actually wire them up in the end. Whether it's wired or wireless, the principle remains the same. You've got to form a matrix of connections between all the key switches that you put in. You've got to hold them in place, and if it's anything like the job I did, you get everything in place, get your switches soldered up, and then you hot glue the bejesus out of it to try and keep everything in place. So if you look inside these cases, it looks like slime has been living there for a couple of months. So my advice would be, if you're going to build one of these things, go the wireless option. If you know the kind of switches that you want, forget about all the hot swap stuff, or get one of the cases printed which has like a recess in for the hot swap switch, so you've not got to bother soldering that in. You're literally just going to push your key switches in and then solder the actual hot swap sockets themselves. Or if you're not bothered about hot swap, by far the simplest is to just stick the key switches through and connect them directly to each other with diodes and a strip of copper tape. The only downsides to, or rather the only extra complexity with the wireless builds is, on the good side, it means you haven't got to worry about wiring up the connections for the TRRS cable, which you need to with the wired one. There's a couple of things which you do need to add, probably. You're going to want a reset switch in there, which, to be fair, you get that on the wired ones too. But you're definitely, I think, going to want a little simple on-off switch, just because ZMK, I've found, has a tendency to keep waking my computer up from time to time. And if you want to travel with this board anywhere, you almost certainly don't want it switched on emitting Bluetooth signals constantly, or it might get something resting on the key, so it's continually wearing the battery down. So I thought it'd be useful to sort of give you a rundown of all the bits and pieces that you're going to need to build one of these things. So to start with, you're obviously going to need 2 cases, switches to go on the inside, and a bunch of keycaps. You need 2 Nice Nano boards, which are the little PCBs that drive the wireless side of things. 2 of those. If you gain the single PCB option, this one is an Amoeba PCB, and these are the things that you stick in. Switch goes in there, that sits the back of the board, and you basically wire to and from those. So you can see that one's just got the hot swap socket stuffed in there as well, just to show you. You're going to need at least 62 of those, but you tend to get them in strips of like 100, and they're fairly inexpensive. But these ones are Amoeba Royale version 2s. Inside the board, I bought a couple of these, and what that lets you do is run a cable from the controller itself inside the board and give you a nice clean charging USB port there, which you can see on. That gives you a kind of proper USB port there. You're going to need a couple of batteries. These ones are 1000 mAh models. Yes, 1000. Battery lasts ages in these wireless builds if you get a decent sized battery, and because of the cavity of the Dactyl, you can get a decent sized battery in there. So I'd go with the 1000s because there's no good reason to go with a smaller one. You know, a boatload of little screws to put your case together. You're going to need at least a couple of these little pin switches. They're what you use for the reset switch. You're going to need like 10, 20 of these, which are the little kind of, these are basically like the soft closers off furniture, cupboard doors, but you use those to stick around the bottom of the case. These you're going to want about 100 of, particularly if you're not going the hot swap route, because these will form the bridge between your switches. These are diodes. These are 1N4148 diodes, so they're very, very inexpensive, like 4 or 5 quid for a pack of 100. Even though you can get surface mount diodes, I prefer these ones. This is like one I've pre-bent there, because that'll just nicely slot through the hole where it needs to on the board itself. So I would say go with those ones regardless. You're going to want a bunch of these little brass inserts. So basically what you do is when you get your case, it'll have hopefully little holes here, you know, at various points to screw into. But what you do is you get the tip of your soldering iron in the end of that, and it heats up very, very quickly, and you basically just push that into the recess and it melts it into place. So you solder tip in there, push in very gently, and as soon as it goes flush, you just pull your soldering iron out, and that will then sit nicely in place. These are DuPont, I think it's pronounced, connectors. Very, very useful. Get yourself a boatload of those, because not only can they directly connect from the pins on the controller board, you can also use them, you snip the ends off one side and use them to get around other parts of your board as well. Those are quite short. You probably want the longer variants like that, and because these are like various colours, it helps when you're sort of planning to use the same colourway on each side, so you know that the right thing's going to the right thing. And then also if you're doing the wireless one, you're going to want some on-off switches. So that's 4 little on-off switches, and they just connect. You connect basically 2 of those pins. Again, all the little sort of electrical components are quite inexpensive, but because there's so many of them, you know, it does add up. And then beyond all that stuff that you need in terms of actual materials, you're going to need some basic stuff regardless. You're going to need a decent wire, you're going to need a soldering iron. A flux pen would be good, where flux is, my sort of rudimentary explanation is, you basically just put that in your electrical points and it helps the solder only adhere to the metal and not splodge all over the shop. This stuff is fantastic. This is copper tape, and when you're doing the columns of your key switches, you can use this instead of soldering wire between each point. You basically just get yourself a strip of this, cut it to the length of your column, stick it over the switches so that you pin, if you imagine like that, coming down, and you put it on one side of the pin switches, sorry, the switches pins, you put it on one side, you push the copper tape over it, and that makes the electrical connection. And then if you want to be extra specially certain, you can just put a blob of solder on each of those pins over the top. You then need to use a non-capacitive tape over the top of that, just so that when you start laying out your diodes as the rows, they don't cross, you know, and touch and cause an electrical contact. So the very quick overview of how you build these is you get your case and you stick your switches through. You run your copper tape over one side of the key switches, push that in, put a blob of solder on top of each of those. You're going to want to put the brass receivers in here, and with a soldering iron melt those in. Then you're either using a diode per switch or a per switch PCB. Yeah, so you're either using a per switch PCB or just wiring the switches directly with one of the diode legs. And you're going to do that as rows for each of your rows. And if you are using these to form your rows, you find if you make yourself a little jig, which I made this incredibly impressive jig to make my LEDs, so basically I could rest the LED on one side, wrap the pin leg round, and that was one of them done. You're going to need to do that like 70 times, so it's worth doing that just to make sure they're all uniform. And that means you've then got your diodes ready to just plonk into position and solder onto each thing and form your rows across the switches. Let's suppose we've got our matrix done of columns and rows. You're then going to get your DuPont connectors, snip the ends off, pull apart however many you need, and you're going to attach to the top part of each column, and you're going to get another set attached to the ends of the rows. They are then going to connect to your nice nano board. So I don't know how many there is on each side of here. About 12 a side. You connect to those, and it's useful to make yourself a diagram in advance of what you think you're going to connect to each different pin on the nice nano, like column 1, column 2, column 3, column 4, and row 1, 2, 3, 4, 5, etc. on the other side. I found that invaluable, and it's especially useful when you get to the stage when it doesn't work, which it probably won't work first time. And it means that when you ask for help somewhere, you've at least got some idea of how this thing is wired together, and you can show it to people and they can go, that's stupid, do it this way instead. And the on-off switch and the reset switch, you're going to need to drill a hole through the bottom of your case and then hot glue them into position, or if you've got a better idea of how to hold them in place. But basically they need to withstand the fact that from time to time you're going to want to toggle the switch off to turn it off, or you might want to double tap that to put it into bootloader mode, which is the reset one. And then in the end, you're going to connect one end of that to your nice nano, and the other end is going to come out through the recess in your board. And then obviously you've got to do that whole thing twice, once for each half. Now the wireless ones at the minute are powered by ZMK, which is open source software. You flash it onto your nice nano. The process for getting software onto the Dactyl is that you make a fork of ZMK's repository on GitHub. You create your key map, and like all these things, it's easier to start if you can find something that's similar to what you want, or even better, exactly what you want. You can fork that code, stick your key map in for your board. I made a new board name because I couldn't find one that had the exact layout of mine. Figure out your key map and your rules. You need to go to the ZMK site, read up about what exactly you want. There's a bunch of stuff in there. The documentation on the ZMK site is very good. Make your firmware, you commit it to your local repository, push it up to your fork, and then GitHub Actions will pick that up and it will run a build process. It takes like somewhere between like 2 and 5 minutes typically, and that will generate you, on the off chance that it actually works, it will generate you an asset, which is the firmware. And I say it might not be right is because typically you're messing around with this stuff, trying to get it to do what you want to do. I had a high failure rate just because I was a bit inept at using it. Nothing wrong with the ZMK software per se. It was my inability to get it to do what I needed it to do. You get the files down, you stick your board into bootloader mode by clicking the reset switch twice, and then the ZMK firmware comes with 2 files, one for each half, and you just drag the file for each half onto the board, that you've currently got connected. Sorry, you have to connect it by USB, put it into bootloader mode, drag the file across. After about like 10 seconds, it will eject itself, and that half's then ready. You do the same thing with the other side, and then you're ready to go. When you do get stuck with the software, and the likelihood is that you will, obviously read and reread the ZMK software, but then go to the ZMK Discord. It's a fantastic resource, and there's absolutely no way I would have got my board working without the help of the people on there. So big shout out to them. So at the end of all that, you'll have a working Dactyl. Now, it will have cost you somewhere in the region of, like for me, about 250 quid. That's just raw cost. I don't even want to think about the amount of time that it spent to get it built. And I've even gone as far as making homing keys there with a hand drill, a little tiny hand drill and a ball bearing. You can just see there. Yeah, so about 250 quid. These are fairly cheap keycaps as well, so obviously, depending on what keycaps you put on there, that's going to push the price up there. But not cheap. Not cheap for something handmade. Let's put all this to one side, the cost. Let's put aside the frustration in getting it built, the frustration in getting the software up and running. Let's just have a think now about what this is like to use day in, day out. In case you skipped the last bit, you should know at this point that building one of these is not cheap. It takes a lot of time and frustration, and at the end of the day you've got a product which has got no warranty. Well, the first thing I would say is that these concave key wells are very, very comfortable. I don't think you can sensibly argue that they aren't a good idea. You know, keyboards like the Maltron have been doing this since the 70s, and then obviously the modern day sort of champion of this layout is Kinesis with their Advantage line of keyboards. You know, it's undeniably very, very comfortable to use. I don't have any complaints about that at all, and I think as I'm sort of looking to get the ultimate form factor for one of these split keyboards, I think the keywell is probably really up there as something that you want to have. And also, because you can put whatever switches you want in there, you can obviously get the switches that you absolutely love. At the minute, my favourite are these Gateron Oil Kings, which are fairly inexpensive, but they come pre-lubed, so you've not got to go through all the hassle of opening up key switches and individually lubing them, which I just don't have any enjoyment doing that kind of thing. So the fact that you can have exactly the switches they want and exactly the layout that you want, I'm not convinced having hot swap in these is that good. If you want hot swap, make sure you get the ones where the hot swap connector fits inside the case itself. Having done these with per-key PCBs, I've just found that on the odd occasion that I do, you know, perhaps one of the switches is bad and I wanted to pull one of the switches out, put a replacement switch in. Even doing that, I'm not swapping all of the switches, just doing that often as I push the new key switch in, it'll just pop the hot glue off the back and the whole PCB, the little one key PCB will just fall out the back, so it means you've got to go back into the case, fix that up, glue it back down. I'm just not convinced it's that resilient. I guess the takeaway is that this thing is only going to be as tough and well put together as you can make it. But the good news is, if you're looking at the inside of mine and thinking what an absolute horror show it is, and you can probably do a much better job, then maybe this is a project for you and you're going to be fine. So this brings me to the really bad news, I suppose. After 6 or 7 months of using this keyboard, I've had to stop. And the reason I think that is because if you look at how my fingers rest there on the home row, and then you look at where that first thumb key is, it's really quite close in line with my fingers there. Now that's not the case with the Moonlander or the Advantage, a lot of other keyboards, and is really, I can only really blame myself for that, because I didn't consider when I was choosing the layout for this board and how to print the case where my thumb would sit. Now on the left hand side this is even more pronounced for me, because this key here I was typically using for command, which on a Mac gets used quite a lot. So, you know, command and copy, command and paste meant me just about kind of putting my finger into this sort of pinched feel here, where I have to bring my thumb right in underneath the digits of my fingers. Now obviously you may have noticed I'm a little bit short of usable digits, so I can't afford to get another one out of action. Even with that solved, let's suppose what I ended up doing to solve the problem and make it more comfortable with this particular piece of hardware is I moved the command key in the mapping from this key here to the outer key here, so it meant that more often than not my hand was spread out, my thumb was spread out a lot more from the other digits. However, even with that problem solved, I don't know if you can see here, but there's perhaps sort of 1.5 inches of height here from the surface that this sits on to where your hand sort of comes up and over the top of and into the keywell. Now the problem with this is, unless you're super vigilant with hovering your hands over the keyboard, you by default tend to rest the palms of your hands down onto the desk. So what it means is that your wrists are kind of doing this kind of thing with your wrist bent up, which, as you can probably tell, is not going to be great long term. If you're getting one of these, I would strongly suggest that you get a wrist rest. And despite how awful I think they look, the Dactyls that you can get pre-printed with built-in wrist rests are probably going to be the best solution, because they're always going to move around, as you move the half of the Dactyl round. But without that, I really think you need something there. I suspect that over a longer period of time, that's going to give you, most people, some sort of problems in their wrists. Now, of course, like all things ergonomic, this is a very personal thing. What are problems for me might not be problems for you, but I'm somebody that's been lucky enough to never suffer any kind of discomfort from typing over the years. And to start to get that when using this keyboard has obviously sort of been a big red flag for me, and has made me shy away from using it. So to conclude this, with a Dactyl Manuform, you can in some ways get the perfect keyboard for you. The right switches, the right layout, the right tenting. It's entirely up to you. You can choose wired or not wired, whether to have perky LED or not, whether you want OLED screens or not. The sky's pretty much the limit. The flip side of that is that getting one of these made is a massive undertaking, and it's by no means cheap. Like, honestly, if you go like for like on the keycaps, for example, you're really not going to be far away in terms of cost compared with something like a ZSA Moonlander, which, or you know, like a Digma Rays or the forthcoming Defy. And when you factor in just how nice the build quality is with those and how good the software is that lets you change your key mappings, it's kind of hard to justify going down this path unless it's exactly what you want. If you do go down this path, I implore you to pay more attention than I did about your thumb clusters and your key layout, and make sure in particular, you know, that you've got plenty of room between these thumb switches that you're going to use most often and where your index finger is on each hand. Because the truth of the matter is, I went to the trouble of making a keyboard that I thought was going to be more comfortable when I didn't have any hand pain, and I ended up with a keyboard that when I'd used it for a prolonged period of time, it actually caused me hand pain. So in many ways, the journey has been worth it for me with the Dactyl, because I'm absolutely sold on this idea of a keywell. I think it's a good thing, but this in itself is not going to be my end game. So for me, the next thing that I'm going to be looking at is the Advantage 360, which I've been working with for a few days now, and I'll have a full review of that very shortly. So I guess the best thing to say is that the Dactyl might just be the perfect keyboard for you. I just don't think it's the perfect keyboard for me. Thanks for watching. If you haven't already, please like and subscribe, and I'll see you again in the next one.